Hello, and I'm glad you found the video for 3.9 Euler line. Now, it's spelled E-U-L-E-R, but it is pronounced Euler, and he is one of the most famous and most influential mathematicians ever. He was around in the 18th century, and he was hugely influential, incredibly smart. He worked in mathematics, he worked in physics, he worked in other sciences. What you know so far is going to be what we learned today, Euler line. He is the first to use the function notation. A lot of what he did in math was higher level math that you have not gotten to yet. A lot of stuff in mathematical analysis, a lot of stuff in calculus. So as you get in higher physics and higher mathematics, you would probably hear more about him if that's where you continue to go. But for now, if you want to pause it and look at the dealer's dilemma. It's a whole question here, and it would be something where I would give you some extra credit, and it is a critical thinking problem. So you can go ahead and pause that, and I'm going to move on. So the first thing we're doing is a blank page. What I'm going to fill in with this blank page, and what I want you to write down and draw with me, is a triangle in which we are going to draw the circumcenter, the centroid, the orthocenter, and the incenter. So we're going to do that here in a second. So let's go ahead and draw that triangle. Let's not make it an equilateral or an isosceles. It can be acute, it can be obtuse, but just make sure it is not equilateral or isosceles, so you can see what it would look like for any triangle. So let's go ahead with the incenter, which, if you remember, is the three angle bisectors, the intersection point of those three. So I start and I make an arc. I go to those two intersection points. Again, this is a great time to kind of look if you are confused on how to do any of these. I will do one as we go along, and then I'm going to pause the video and just do it myself so you don't have to sit and watch this whole time. So I made an arc. I went to the two intersection points of the arc, and I made two little arcs that intersected. And now I'm going to go from the angle through those intersection points, and that's your angle bisector. Now I want you to do this along with me, so I should see this in your notes. Remember, they're going to be collected on Wednesday by the substitute teacher. So go ahead and make all three of these. And there you can see the incenter. So we're going to draw a little point. And on yours, please label that the incenter, and I'll write IN. But do label that incenter. Now you're going to go ahead and find the circumcenter, and you're going to find the orthocenter, and you're going to find the centroid. So we do the perpendicular bisectors for the circumcenter, and again I will do one of these. If you remember correctly, you go over halfway. Make sure you go over halfway. I will make it green. And then you draw your arc. And you can come all the way through if you want. I'm not going to, because then it'll look very messy on the inside. I come over here. I line it up on the other side. And I draw this arc, and you can see I didn't draw the first one big enough, so I continue that one. For that intersection point, I come back to this point, and that one will have an intersection. I get my straight edge, and I connect those two. And now I want you to do that for the other two sides. And there I have my circumcenter, and I'll draw that point in green. And I want you to label that, and I'll write CI for circumcenter. So we have our incenter, we have our circumcenter. If you remember, I had labeled this. And now you want to do your orthocenter. Well, if you remember, is your altitudes. So you're going to do your 3 altitudes. And again, I'm showing you all these one time. So again, you have a little more practice learning these. If we do altitudes, I go to an angle. And we'll make this a different color. And I go a little bit past the other side. So I'm going to make sure my compass is big enough. And then let's go to this side. So go a little bit past. We draw the arc. It intersects twice. We go to the first intersection point. We can change this if we want. We draw the arc. We go to the second intersection point. We draw the arc. You can see this consistently is happening with me, and so it's okay if it happens to you. If not, that's even better. And you just make sure you draw it. So there's the intersection point, and you connect that from the opposite vertex. And you connect that. That's our altitude. 3 of those gives us the orthocenter. So go ahead and create 3 of those. And you look there. So I have my 3 points, my incenter, my orthocenter, and my circumcenter. And I want you to go ahead and create the centroid. You should know how to do that on your own. So take a second to do that. And so there we have it. I had to redo one of them. But I have the incenter. Whoa. I have the incenter is the red lines. I have the circumcenter is the green lines. I have the orthocenter is the black line. And then I have the centroid up here up top is the one I had to redo. And it is on up at the top. And what you'll notice is that the circumcenter, the orthocenter, and the centroid all lie on the same line, and that is the pink line. So the Euler line conjecture, which you need to write down underneath your drawing, is the orthocenter, centroid, and circumcenter are the 3 points of concurrency that always lie on a line. I remembered it from when I was in high school. The orthocenter, the centroid, and circumcenter, I remembered it in that order. So it was OCC, and it was very similar to one of my favorite songs. So I remembered it. You know the OCC? Yeah, you know me. You know the OCC? Yeah, you know me. You know the OCC? Yeah, you know me. Who knows the OCC? All the mathies. And so that's how I remembered it. None of you maybe know the song OPP by Naughty by Nature, but I do. I love it. And this fit in really nicely. So OCC. Orthocenter, centroid, and circumcenter are the 3 points of concurrency that always lie on a line. So our next conjecture is the Euler segment conjecture. The centroid divides the Euler segment into 2 parts, so the smaller part is half of the larger part. So you already have your drawing. I'm not going to take you through a whole nother drawing. You already have your drawing, and so you need to look at your drawing and see if that's true. What should happen is the ratio formed by Euler's line. So the ratio formed by Euler's line with the centroid being the middle point is always 2 to 1. And the Euler segment is the centroid divides the Euler segment into two parts. The smaller part is half of the larger part. You guys do need to know ratios. They write it just like this, 2 colon 1. That means the ratio is 2 to 1. And it basically is saying that the smaller part is half of the larger part. Use your compass, use a ruler, take a second, pause this video, and measure it to make sure you did it right. You did it correctly. And then here we have used the previous conjecture to solve this problem. So what we're going to do is we have this line segment AC, and it's a Euler segment. They tell you this. It's containing 3 points of concurrency. A, B, and C are the points with AB greater than BC. And AC, the whole thing, equals 24 meters. So you know AB is greater than BC. I drew it like this specifically so you stop relying on pictures to tell you what's true or not. It looks like AB is smaller than BC. If you measured it, AB would be smaller than BC. But the problem tells you AB is greater than BC, which means you have to assume that AB is greater than BC. It doesn't matter what the picture looks like. So if the whole thing's 24 meters and it wants you to find AB, you have to remember how to do this. And the way you do it is if they give you the overall length, it's the hardest way. If they've given you AB and they say AB is bigger than BC, you divide by 2 to get BC. If they give you BC and they say BC is smaller than AB, then you multiply BC by 2 to get AB. But here, they give you the full length, which is 24. And they give you that AB, from the conjecture, AB is twice of BC. That means there's 3 parts. That means there's 3 different parts of this. And so, exactly the same as the centroid. If we're trying to find the bigger of the 2 lengths, and they give us the full one, we multiply it by 2/3. If we're trying to find the smaller of the 2, we take the full one, and we multiply it by 1/3. So I want you to write this down. I want you to have those answers on your paper. I'm not going to give them to you because it's just the multiply. And that is all you need to know for the Euler problem. I believe throughout this whole segment there was a good period of time where I was calling it Euler. I apologize for that. It is Euler. I will not be upset if you call it Euler. Just know that it is pronounced Euler, and I might have been pronouncing this wrong this whole time. I was wrong, just like all of you were wrong about Taylor Swift not being as good as Katy Perry. It's a ridiculous comment, just like saying Euler is a ridiculous comment. Enjoy your night.